Hello friends, I'm Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today we are going to discuss a new topic, that is probability. So let's proceed to understand the basic concept of probability. So the heading of our today's topic is Introduction to Probability. So today we are going to discuss or start our discussion on probability. Now, what is the meaning of the term probability? This term or word probability means chances. So, if we are calculating probability of something, then that means we are calculating the chances of happening that particular thing or that particular event. Now, this probability, the concept of probability based on the outputs obtained from one particular practice, and that practice is called experiment. So from experiment all these things used to happen, events or different cases are created, or those are the outputs of the experiment, and we have to calculate the probability of those events or cases based on that experiment. So let's start to discuss our topic from the origin of probability, that is experiment. So what is an experiment? An experiment is a process of doing or observing something that happens under certain conditions, resulting in some final outcome. If we are doing something or we are observing something to be happening under a certain conditions which result in a final outcome, then that type of practice is called experiment. Okay, let me give one example of experiment, just like tossing the coin or tossing more than one coins at a time or rolling a dice. So these are all few examples of experiments. Here in the experiment we used to get some result. If we toss a coin, we'll get either a head or a tail, or maybe it will be neutral. Similarly, if we are rolling a dice, then we can get any number in between 1 to 6. So we can say that an experiment is a process of doing or observing something to happen under certain conditions which result in some final outcome. Okay friends, now let's come to a special type of experiment that we need for our discussion of probability, and that special type of experiment is called random experiment or statistical experiment, or it is shortly called trial. So what is that random experiment? A random experiment is one in which it satisfies these three conditions together. And what are those three conditions that a random experiment satisfies? The first condition is that all possible outcomes of the experiment are known in advance. We should know all possible outcomes of that experiment. Just like if we are tossing a coin, that then we know that either a head come or will a tail will come. So we know that the all possible outcomes, those are head and tail in tossing a single coin. This is the first point. The second condition is that a performance of an experiment result in an outcome which is not known in advance. Let me explain you this point through that tossing of coin. If we are tossing a coin, that we cannot predict that a head will come or a tail will come. Anything can come. The third condition says that the experiment can be repeated under identical conditions. We should repeat that experiment under the same conditions up to any number of times. That means if you are tossing a coin, then we should toss the coin any number of times under the conditions. There shouldn't be any restrictions for that. So if an experiment satisfies these three conditions, then that experiment is qualified to be called as random experiment or trial. Now what is outcome of that random experiment? A possible result of the random experiment is called its outcome. If you are tossing a coin and we are getting a head, then head is the outcome of that random experiment of tossing the coin. Then come to sample space. What is sample space? The sample space, the set of all possible outcomes of a random experiment, is called sample space, and it is denoted by the letter capital S generally. So sample space is the set of all possible outcomes of a random experiment. If you are tossing a single coin, then we will get a head or a tail. So a set of head and tail together as elements is called the sample space. Then come to sample point. An element of the sample space is called a sample point. An element of the sample space is also called an sample point. It has another name also. It is also called elementary event. Sample point is same as element event in many cases. Then come to event. Event, it is a subset of the sample space associated with the random experiment. So any subset of a sample space which is associated with it, with the random experiment, is called an event. So here our aim will be to find the probability or chances of this event with respect to the sample space, as event is a subset of the sample space, or mathematically we can say that event is a subset of the sample space S. So to get the probability of the event, or to get the chances of the event, we must compare it with the superset, that is sample space. So event probability is calculated with respect to its own sample space. Okay friends, now let's discuss different types of, or few different type of events. Our first event of discussion is impossible event. As I told you, any subset of the sample space will be termed as an event. So phi or null set or empty set is definitely a subset of the sample space S. So this phi set or null set or empty set is known as impossible event, because it does not contain any elements inside it. Then sure or certain events. Here, as we know that every subset is the subset of itself, so S is also the subset of itself. That's why S is known as the sure event or certain event. Then come to our next term, that is equally likely or equiprobable events. These equally likely events or equiprobable events are coming under uniform spaces or uniform events. So what is that equally likely or equiprobable events? The given events are said to be equally likely if none of them is expected to occur in preference to the other. That means they have the same probability. If you have few events under the same sample space and they have the same probability, those events have the same probability, then they are called equally likely events. Now the fourth type of events is mutually exclusive events. So what are mutually exclusive events? A set of the events are said to be mutually exclusive if happening of one excludes the happening of the other. That means if one event does not depends on the other event for its happening, or is not affected by the happening of the other event, then those events are said to be mutually exclusive. Mathematically, we can say that if A and B are two mutually exclusive events, then their intersection is fine. That means they are disjoints. They don't share any common elements. Now, our next event is exhaustive events. A set of events is said to be exhaustive if the performance of the experiment always results in the occurrence of at least one of them. That means if we are performing the experiment, then any of the events, at least one of the events of that sample space will occur. It will not happen that you do the experiment, random experiment, and no event is occurred. It will not happen. That means mathematically we can say that if E1, E2 up to En are exhaustive events, then their union will result in the total sample space. That will, if you combine or if you unite all the events, they will form the sample space S. If you do so, then they are called exhaustive events. Okay friends, now come to complement event. Let A be an event in a sample space S, then the complement of the event A is the set of all sample points of the sample space S other than the sample point in A. That means the complement event of A contains all the sample points of the sample space S which are not in A. Okay friends, let's try to understand this mathematically. Let's see the symbols used for it. The complement of the event A is written as A dash, or it is also written as A open C, or sometimes it is written as A overscore. A underscore it is written. So now the literal meaning of the complement of A is, it is S difference A, the sample space difference the event A. That results in the complement of A. So we have three symbols, and in different books different symbols are used. So you can use your symbols according to your own compatibility. Now before moving for our probability main formulas, let's discuss some frequently used verbal description of events. That means how to symbolize or how to represent an event with short symbols, short letters, instead of their broad or elaborated verbal descriptions. If I have to write not an event A, not A, then I can write it as A complement. If I have to represent an event which contains A or B, that means at least one of A or B, then I can write shortly A union B. If I have to write both A and B events together, then it represents A intersection B. A but not B, it is written as A intersection B complement. Remember, only B's complement is here, A is free, which is also equals to A difference B, and which is same as A difference A intersection B. So this is a very important formula which we will use later in many problems. Now to represent neither A nor B, we can write A complement intersection B complement, and we know by De Morgan's law it is A union B's whole complement. Now to represent exactly one of A, B or C, then it will be represented as A intersection B complement intersection C complement whole union A complement intersection B intersection C complement, whole union A complement intersection B complement intersection C complement. You can see three intersections combinations are taken and they are united, but in that intersection parts only one is free, other two complements are taken. If complement is taken, that means they are not considered in that. That means if I am writing A intersection B complement intersection C complement, that means I am not including B and C, I am including only A. And this is in this way three possible cases will come, and I have to unite them together to get the representation. So exactly 2 of A, B or C is represented as A intersection B intersection C complement union A intersection B complement intersection C union A complement intersection B intersection C. So friends, like this we can do more experiments on the verbal description of events, and we can represent the events symbolically for our simplification or calculations. Now come to the probability of an event. The probability of the event A is shortly written as or symbolically represented as P of A. Here we can write capital P or small p, but generally capital P is used for the representation of probability. So the probability of the event A, which is P of A, is nothing but the number of favorable cases to the event A by the number of exhaustive cases in the sample space S, which is equals to n of A by n of S. Now to remember it more simple way, we can say that the probability of A is nothing but size of A by size of divided by size of S, which we are writing cardinality of A by cardinality of, but reading it cardinality of A and cardinality of S will be not so correct. The best term will be size of A by size of S. Why actually we are using size here? That let me tell you shortly that an event or a sample space are nothing but sets. There are few sets. So a set contain numbers or elements in it. Now we know that sets are of two categories. They can contain real numbers or they can contain natural numbers. That means they may be finite sets or infinite sets. They may be countable sets or uncountable sets. So if that set which forms the event or sample space contain real numbers, then it will be very hard to count the exact number of elements in that set. But we know that what is the range of that set, but we cannot properly count the number of elements in that set. So that's why in that case writing cardinalities in the or using the word cardinality or number of elements of events or sample space will not be correct. So the better word will be the size of the event by the size of S. Okay friends, now we come to know that probability of A of the event A is size of A by size of S. Now let's discuss few important properties and formulas of probabilities before moving to problems. The first property says that the probability of any event is bounded in between the numbers 0 to 1. That means the probability of any event is always in between the number 0 and 1. That means probability of an event cannot be less than 0 or more than 1. It is a number in between 0 to 1. Okay. Now the probability of the impossible event is always 0 because it is not going to happen. The probability of the sure event S is always 1 because it will definite to be happen. Now the probability of A complement of the event A complement That means the probability of not happening of A is equals to 1 minus probability of A. We can interchange their places, and we can also write that probability of A is equals to 1 minus probability of A complement. Both are same. The fifth property says that if we have two events under the same sample space S as A and B, and if A is the subset of B, then the probability of A will be less than equals to the probability of B. That means the smaller event has less probability, and the larger or super event has the more probability compared with each other. They have the chances. Now the sixth property says that the probability of A intersection B complement is same as probability of A difference B, and whose exact formula is probability of A minus probability of A intersection B. So this formula is going to help you a lot. Seventh property says that the probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Now, if A and B are two mutually exclusive events, that means they are disjoints, that means A intersection B is equals to phi, then the probability of A union B will be probability of A plus probability of B, because here the probability of A intersection B will be 0, as A intersection B is phi here. Okay. Now our last property here is probability of A union B union C. If you are taking three events under the same sample space as A, B, C, then the probability of A union B union C will be equals to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Okay. So from this you have already observed that probability has something or somehow mostly related to set theory. The properties and formulas are set theory are carried on in probability also. So they have a big relationships. So till now we discuss the different terms and definitions of probabilities and random experiments. We come across different few properties of probabilities of an event. So friends, now it's time to discuss all these things through a problem. So let's take a problem to discuss all these things. Here I have taken an example of a card problem. Here a card is selected from 100 cards which are numbered from 1 to 100. We have 100 cards on which numbers are written, and those numbers are 1 to 100, natural numbers. If a card is selected at random, if randomly or haphazardly we are selecting a card out of that 100 cards, then find the probability that the number of the card is, the number printed on the card is divisible by 5, divisible by 2, divisible by both 5 and 2, and divisible by either 5 or 2. We have to find out the probability of 4 different events here. So before moving for the problem, let me tell you that while solving any probability problem, your first task will be to read the question carefully, and first thing you have to do is you have to judge the sample space, because without sample space you cannot calculate the probabilities. So first of all you have to understand that what is the sample space here in this problem, and then you have to name it as S, and then you can proceed for its size, the size of the sample space S. After that, in each bit of the question you have to name its, or you have to mention the name of that event, particular event of which you are going to find the probability with explanations. Then try to find out the size of that event, and then go for the formula of probability, which is very simple to calculate. So here, what is the sample space? here a card is selected from 100 cards which are numbered from 1 to 100. So let the sample space is S, whose size is 100 here, because here the number of cards is 100 and we have to select any card out of that. So that's why the sample space, the size of the sample space is equals to 100 here. So our first thing is done. Now let's move for the first bit. We have to find the probability of the event of getting a card whose number printed on that is divisible by 5. So first of all, let's name this event of where a number is divisible by 5. So let A, capital A, be the event of getting the card whose number printed on that is divisible by 5. Okay. So let's mention the elements, the type of elements which are included in that particular event, which is a set. Here A is the set or event of getting the element which is in between 1 to 100 and divisible by 5, and those numbers are 5, 10, 15 up to the last number will be 100, and we know we can count that the number of such numbers will be 20. So there are 20 such numbers in between 1 to 100 which are divisible by 5. So the size of the event A is 20. Now the probability of the event A is size of A by size of S, which is 20 by 100. After cancellation, you will get 1 by 5. You can also convert it to decimals if you want. Now our second question is to find the probability of the event where the number printed on the card is an even number or which is divisible by 2. So let's name that event first. Let capital B be the event of getting the card whose number is divisible by 2. And for our understanding, we can also mention that event B include writing some elements starting from the beginning to the end. And we can see these even numbers in between 1 to 100 are 50 in their numbers. There are 50 such numbers which are divisible by 2 in between 1 to 100. So the size of B is 50. Now the probability of B is size of B by size of S, which is 50 by 100, that is 1 by 2. Now our third question is to find the probability of the event of getting the card whose number is divisible by both 5 and 2. If a number is divisible both 5 by 5 and 2, then we can say that it is divisible by 5 into 2, that is 10. So the numbers which are divisible by 10 in between 1 to 100, they are 10, 20 up to hundreds. And that set of getting card which is divisible by both 5 and 2 are represented as A intersection B. We don't need to represent or write any other name here. With the previous A and B terms, we can mention it. It is A intersection B because both is happening here. Now the size of A intersection B, we can count there. How many numbers total? 10 number of numbers. So size of A intersection B is 10, and the probability of A intersection B is size of A intersection B by size of S, that is 10 by 100, that is 1 by 10. And last question is to find the probability of the event of getting the card whose number is divisible by either 5 or 2. And this either 5 or 2, this event is, we can symbolically written as A union B, as we have discussed earlier. Now for that, we don't need to calculate the size of A union B, which will be very hectic here. Better to use the formula for A union B probabilities. A union B probabilities, probability of A union B is probability of A plus probability of B minus probability of A intersection B, because all these three factors we have already calculated in previous steps. So now we can use it to get the answer of A union B probabilities. Now put the values here, calculate it, and you will get the probability of A union B as 3 by 5. So this is a small example, friends, where I try to understand to cover up few of the formulas or probabilities. There are many lot of problems waiting for you to be solved. Now, till now we discussed that the probabilities can be categorized in two groups depending upon the events or the type of events or type of sample space. If the sample space contains elements which are equiprobable, that means they are equally likely to happen, that means every element's occurrence are equals to each other, their chances are equal, their probability are equal, then they are called equiprobable. If the chances or the probabilities of happening of an event or an element of the sample space are not equals to each other, they differ from each other due to some deformity or some unconditional cases, then it is called non-equiprobable or non-uniform sample space or non-uniform sample space. Let us discuss that one also. Now, when this non-uniform or non-equiprobable cases happens, let me give you one example of a coin, tossing of a coin. Say a coin is a fair coin. If I am saying fair coin, that means I want to mean an unbiased coin which is not partial to any of the outputs. We know that a coin has two faces, one head and one tail. If we are tossing a coin, a fair coin, that means an unbiased coin, then the chances of getting a head or a tail will be equal, and that is 1/2, we know. But say there is a manufacturing defect of that coin, that means say while manufacturing that coin there is some deformity, or the coin is produced properly but after formations due to some accidents that coin get damaged partially. So by that, the coin, while tossing the coin, we are getting one biased result. That means it is somehow either the chances of getting head or tail is not equals to the chances of the other side here. Then it creates one non-uniform or non-equiprobable space. So non-uniform or non-equiprobable space are the sample spaces where the elements do not carry an equally likely cases. They don't carry equal chances of probability or equal chances of happening. So in this case, how to find the probabilities? So in general, if a finite sample space is not equiprobable, then the probability can be assigned to the elementary events, and the probability of any event is the sum of the probabilities of all the points of that event. If you want to calculate the probability of an event, then we can use the formula that we can add all the probabilities of the individual elements of that event. Now adding the probability of each and every element of the event will help us to get the probability of the whole event in case of non-uniform or uniform spaces. It helps you in both the cases, non-uniform cases and uniform cases, but in non-uniform cases we need to use it. In uniform cases we are not required to use the probabilities of individual elements, because there we have a fixed or certain formula, a clear cut formula. But here, as due to the lack of clear cut formula, to get the probability of an event we have to add the probability of each and every element of that event. So let A be the event which contains the elements A1, A2 up to An. Then we can say that the probability of the event A is equals to the probability of A plus probability of A2, A1, A2 plus up to probability of AN. That means the summation of probability of each and every element will result in the probability of the whole event. So extending this concept, we can say that a sample space, the probability of each and every element, the sum of the probabilities of each and every element of the sample space is equals to the probability of the sample space, and that is always 1. So we will use this concept to solve the non-uniform or non-equiprobable spaces problems. Let us discuss one example to conclude it, friends. The example we have taken are of horses in the arena. Arena is the fence or the area where horses are kept. So only 3 horses A, B, C are in the arena. There is an arena where 3 horses, namely A, B, C, are there. B is twice likely to win as A. Those 3 horses, they are running in the arena. Let me tell you, arena where the horses are kept and where they have specific strips or tracks on which they will run. So it is all about the racing of horses, and there are 3 horses ABC. Now if they are racing with each other, then they have chances of winning. Now here 3 horses A, B, C, they don't have equal chances of winning. They have different chances of winning compared to each other. Now what is given in the question? That B is twice as likely to win as A. That means the probability of B is double of probability of winning of the horse A, and the probability of the winning of the horse C is 3/2 times likely to win as the horse B. So the question is to find the respective chances of the winning of the race by the horses, each and every horse. So let the probability of the horse A wins is probability of A, that is I am writing as small p. Then according to question, the probability of the horse B wins is equals to twice the probability of A wins, that is 2 into p, 2p. And the probability of the horse C wins is 3/2 times of probability of the horse B wins, that is 3/2 into 2p. After cancellation you will get 3p. Now we know that there are only 3 horses in the arena A, B, C. So the probability of the winning of these 3 horses will be equals to 1 here, because there is no other horse besides A, B and C here. So probability of A plus probability of B and probability of C is equals to 1. Now you put the values in place of probability of A and B and C as P, 2P and 3P, add them together, you are getting 6P. 6P is 1, so P is 1/6. So probability of A wins is P, which is 1/6. Probability of B wins is 2P, which is 1/3. Probability of C is 3P, which is 1/2. So this is an example where we discuss how to find out the probability of the events of a sample space where the sample space is a non-uniform or non-equiprobable types. So friends, we discuss both equiprobable and non-equiprobable type. We discuss all the formulas, the basic formulas required for the probabilities. I hope now you can go for problems and solve as many problems as you can do. If you face any difficulties, you can come to the comment box and ask me your doubts if you need to do so. So friends, thank you very much for watching this video.